So hey guys, welcome back to the channel. And as of this video, this is a video of class 10 and the topic we are going to take is pair of linear equation in two variables. So this is a rather new chapter from the previous chapter which we solved, which was polynomials. In the last class we saw that in the polynomials chapter we started long division method and we saw various division algorithms, and then we saw the relationship between the dividend, divisor, remainder and the quotient. Well, this is a new chapter and it is going to deal with equations only, but in a rather different sense. So, what is an equation? Well, an equation is any statement which has a left hand side, which I will be writing as LHS, and a right hand side, which I will be writing denoting as RHS, and an equal to symbol in between them. So, any equation consists of a left hand side, an equal to symbol, and a right hand side. So let me write an equation and give you an idea of how an equation looks like. So let us consider this equation. 3x plus 2 equals 5. Well, is this an equation? Absolutely yes. Why is this an equation? Well, this has a left hand side which is 3x plus 2. This is your left hand side and your 5 is your right hand side. So this is an equation, a very well example of an equation. Now in this chapter you will be dealing with equations which has two variables. That is what the topic suggests. Pair of linear equations with two variables. So you will be having two variables and we commonly take two variables as x and y. X and y are two such alphabets which we will be considering in this chapter as two different variables. Now what is a variable? A variable is a letter where we can substitute any number in it and we can simplify it further. Let me give you an example. Let me take 3x. Well, 3x. Now I can substitute anything in place of 3x to get some value. Suppose if I put 1 in place of 3x, then 3 and in place of x we will take 1. So 3 times 1 is 3. Now 3 times 2 will give us 6 and 3 times half, which will give us 3 by 2, which is 1.5. Now any such thing which we can substitute in place of x can give us something, then x is a variable. So I can substitute any real number can be substituted in place of x to obtain some value. So now you know what is a variable in a very vague format. Now let us see what are all the equations you will be dealing with. Let me give you an example of one of those. 3x plus 5y equals 1. Now is this an equation? Yes, it is an equation. Why is it an equation? Well, it has an LHS and an RHS. LHS being left hand side and RHS being right hand side. Now what is the LHS of this equation? Well, of this equation the LHS is this part and the RHS is this part. Now you clearly get the concept between why an equation is called so and what are all such examples of equation. Now as of this chapter we will be dealing with two variables as I already said, and the two variables over here are x and y. Now as I already told you, many values can be substituted in place of x as well as y. So let me substitute the value of x as 1 and the value of y as 2. So I am taking two different any random numbers and substituting in place of x and y. Now let me check. Now in case of left hand side, let me take two values 1 and 2 and substitute in this place. So 3 times 1 plus 5 times 2, which will in turn give me 3 times 1 is 3 and 5 times 2 is 10. So 3 plus 10 is 13. Well, when I take x as 1 and y as 2, then I am getting, when substituting their corresponding values in the left hand side of this equation, I am getting 13. Now let me see what is right hand side. Now right hand side of my given equation is 1. I don't have any variables over that to simplify, so it is just 1. Now my left hand side evaluates to 13 when I substitute these following values, and my right hand side is already given as 1. Now there is an equal to sign in between the LHS and the RHS. What does that mean? It means that the value of the LHS, which is the left hand side, must be equal to the value of the RHS, which is the right hand side. Now over here we are obtaining the LHS as 13 and the RHS as 1. Well, you can obviously see that 13 is not equal to 1. Hence, the values 1 and 2 substituted in place of x and y is wrong. So we have to substitute different values in place of the variables x and y so that we can equate these and we can finally get the correct answer on both the sides. So that is exactly what the equation means. The equation means that the LHS, which is the left hand side value, should be equal to that of the right hand side value, and you have to put values of the variables such that they are equal. Now let me give you the same example with suitable values of x and y. I choose 1 and 2 which are random values for x and y, right? Now I will choose suitable values for x and y. Well, now let me try substituting the value of x as 2 and the value of y as minus 1. Now when I substitute it for the LHS, which is the left hand side of this given equation, 3x, instead of x I am substituting the value 2, and instead of y I am substituting the value minus 1. So let us substitute the values. So instead of x it is 2. So 3 times 2 plus 5 times, instead of y it is minus 1. So minus 1 equals, now let us simplify this part. So 6 times 3 times 2 is 6, and 5 times minus 1 is minus 5. Now 6 minus 5 is 1. Now the value of LHS separately simplified is 1 according to this given values. Now what is the value of RHS? Now the value of RHS, which is the right hand side of the equation, is 1. There is no further simplification, and hence it is only 1. Now let us see that LHS and RHS are equal. Now the value of LHS is 1 as we have simplified, and the value of RHS is obviously 1 from the right hand side. So we can observe that LHS and RHS are equal. Hence this forms an equation, and the values we have considered for x and y are correct. Now the values I have chosen for x is 2 and the y is minus 1. Why did I choose those values? Why does only those values can get substituted in this equation and we get the correct answer? Well, not only these two values substitute and give us the correct answer, but there are infinitely many values which can substitute for x and y so that we can get the same value 1. Now let me try some of those. Well, let me choose two separate values such that the same condition is satisfied again, so that I can show you that there are many other values apart from 2 and minus 1 which we can substitute in place of x and y to get the same result. Now let me take the value of x as 2 by 3 and the value of y as minus 1 by 5. Well, I am going to substitute the value of x as 2 by 3 and the value of y as minus 1 by 5. Now let us get started. So according to the LHS part, well, we can simplify it by substituting these corresponding values in this equation. So 3 times what is x? Our x is 2 by 3 plus 5 times our y is minus 1 by 5. Now when we start simplifying this, we can cancel this 3 and this 3 out because it is in the numerator and the denominator correspondingly, and 5 and 5 can also be cancelled. So hence we will be left with 2 plus and minus 1 over here. So what is 2 minus 1? Well, it is 1. So 2 minus 1 is 1. Our LHS value is 1. Now what is our RHS value? Well, we obviously know that the value of RHS is 1. So from this as well we can see that the value of LHS is 1. The value of RHS is 1. Hence they both are equal and we get an equation over here. So the values which we have taken over here are correct. That is the meaning of this action. So from this we can conclude that there are I have taken two such examples, but there are infinitely many examples which I can take so that they are equal. Now how do I choose whether this is the correct one or this is the correct one? Well, everything is correct over here, but what you are going to be dealing with is the chapter's name is pair of linear equations with two variables. So what we are going to deal with in this chapter is that we are going to have one equation over here and we are going to have another equation. We are going to solve those two equations in any method which I am going to specify further in this chapter, and we are going to get the value of x and y. That is all the things that are going to happen in this chapter. So let me give you a glimpse of what is the procedure which is going to happen in this chapter. Now for this chapter's context, I will be taking two random equations, 2x minus y equals 1 and x plus y equals 5. Now we are going to find one such pair which is going to exist so that we can substitute them and find the LHS equal to RHS, which will be common for these two equations. You will understand what I am saying when I start doing the procedure. Now let us substitute the value of x as 2 and the value of y as 3. Now why I am substituting the value of x as 2 and y as 3, I will be explaining it later, but just substitute these values and try and simplify. I will be doing simplification for you. So let us first simplify this equation over here, then we will start with this equation. Now x is equal to 2 and y is equal to 3. Let us take the LHS part. The LHS part of this first equation would be 2 times x, which is 2 times 2, minus y, which is 3, which is equal to 4 minus 3, which is 2 times 2 is 4, right? So 4 minus 3, which is 1. Now the RHS part is going to be 1 as well. RHS is also 1. So 1 over here and the 1 in the LHS when we substitute these corresponding values. Now let us try for this equation over here. This is for equation 1. Now what about equation 2? Well, for equation 2, let us try substituting these values and let us simplify. So in the LHS, which is x plus y. Now x is 2 and y is 3. So x plus y is 5. What about the RHS? Well, RHS is 5 as well. So we can see that the LHS and RHS is equal in both the cases. The first equation is also getting, we are getting the values of LHS and RHS as the same. And for the second equation also we are getting the same values. What does that mean? Well, the values which we have taken over here, x is equal to 2 and y is equal to 3, are satisfying the same case for both the equations. I will be repeating what I said earlier. So the values x is equal to 2 and y is equal to 3, which were substituted in both these equations, provide the same values. So let me take another example and justify the case. So let me take x is equal to 1 and y is equal to 1. Let me take these two values. Let me substitute in place of x and y in both the equations and prove to you that only these values can satisfy this equation. X is equal to 1, y is equal to 2. When substituting this in the equation 1, the LHS part will become 2 times 1, which is 2, and y substituted over here. So 2x minus y. So 2x minus 2 minus 1, which is 1. Well, the first case it is correct because LHS I am getting as 1 and RHS is also 1, as you can see over here. So RHS is also equal to 1. Let me try in the second case. Now as of the LHS, I will be getting x plus y, which is 1 plus 1, which is 2. So 1 plus 1, which is 2. And my RHS, as you can see, is 5. So in the first equation, the first case, we are getting the answer as LHS is equal to RHS. Then this is an equation for this value. But the second case, it is not satisfying. So the values is wrong when you consider two equations simultaneously. Well, the chapter's name is pair of linear equations in two variables, and hence this should satisfy for both these equations. The values which you are taking should satisfy and consider as an equation for both the given equations, which in turn mean that LHS equal to RHS in both these cases. Well, when we take the values 2 and 3, x is equal to 2 and y is equal to 3, then we are getting it satisfied for LHS and RHS to be equal in case of first and second equations. And if we are taking the case x is equal to 1 and y is equal to 1, well, they are not satisfying, and so are many other values. Then you can try x is equal to 2 and y is equal to 2. You can try x is equal to minus 1, y is equal to minus 3, or any such example, and it won't satisfy. Only a few values you can take and get it satisfied is based on the solution of these two equations. Now, why did I choose 2 and 3? Well, that is what this entire chapter is going to be. It is going to be that how do you solve this pair of linear equations, the pair of linear equations with two variables consisting of it, so that you can obtain the values of x and y. Well, there are specific methods to solve them, and in this video we will be seeing what are those few specific methods. When we classify the methods as to which we can solve these equations, well, let me give two equations, two generic equations. A linear equation is when the degree is 1. So according to this chapter name, we are going to handle linear equations and the degree is going to be 1. Well, we saw already that degree is the highest power of a variable, maybe x or y. So if in an equation we have both x and y, then the highest power should be 1. This is a linear equation, 3x plus y equals minus 1. This is a linear equation. But 3x square plus y equals minus 1. This is not a linear equation because the power of this variable over here, the x, is 2. And the degree is also 2 for this variable. And hence this is not a linear equation with two variables. And hence we are not going to deal with this in this chapter and only this. Now, instead of these coefficients, I can replace it with constants such as a, b and c. So ax plus by equals c. Now a can be 3, b can be 1 and c can be minus 1 or any other real number value instead of a, b and c. So a, b, c, all these three values belongs to the real number class. we have represented this equation with a, b and c such that ax plus by plus c is our first equation. Now as of this chapter we are going to deal with two equations. So when I write the second equation as well as ax plus by plus c, it is going to be confusing, right? So I'll differentiate these two equations with the subscript a1x plus b1y plus c1. This is our first equation, and our second equation is a2x plus b2y equals c2. Now a1, b1, c1, a2, b2, c2 are all coefficients of their corresponding equations. So instead of a1, b1, c1, a2, b2, c2, you can have any real number, and these two will behave as linear equation in two variables x and y. Now as I have already told you, there are specific methods to find the values of x and y when two equations are given. So the first method which we will be using or we will be seeing over here is the graphical method. So we can be using the graphical method to find the values of x and y, and the second method we can use is the algebraic method. So the graphical method and the algebraic method, two methods are there so that we can start finding the values of x and y of any two given equations, and we can satisfy both the equations as to LHS being equal to RHS. So this is our primary condition. This should be equal for whatever values we substitute in place of x and y. So the first, as I have already told you, is graphical method, and in graphical method what we are going to do is we are going to plot these equations. Well, you can think, how can we plot equations? Well, I'll address that problem as well. Now let me give you an equation 3x plus y equals 1. This is our first equation. So when I give you this equation can be plotted in a graph. If you think how can it be plotted, well, I'll give you an example. Now represent it in terms of x. So represent it like this: y is equal to something. How can I do that? Just bring this 3x to the other side. Y is equal to 1 minus 3x. Well, if you write it in terms of this, then it will be easier to plot it in a graph. Now what does a graph consist of? A two-dimensional graph consists of a x and a y. So an x-axis and a y-axis, and you can plot any point in this. So it can be 1, 2, 3 and all the positive numbers there, and -1, -2, so -1, -2 over here in the left hand side, and similarly on the top and the bottom. So this would be 1, 2 and so on till infinity, and -1, -2 and so on. So this is your model graph. Now I am going to plot this equation over here. Now you can think, wow, he is being crazy. How can he plot this equation, which is something like mathematical stuff over here? How can he plot it in this over here? This is a visual representation. Well, that is exactly the case. You can plot this mathematical representation into a visual representation using a graph and some techniques. Now start substituting different values of x. So I will take x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3 and so on. Now as of the value of y, I will start substituting x and I will automatically obtain the value of y. How can I do that? We'll start substituting it. The value of x at first is 0. So when you substitute the value of x as 0 over here in the RHS, you will get 1 minus 3 times 0. What is 3 times 0? 3 times 0 is 0. So 1 minus 0 is 1. So y, the value of y correspondingly will become 1. I'll solve it. So y is equal to 1 minus 3x, and in place of x you substitute 0, and 3 times 0 is 0, 1 minus 0 is 1, so y equals 1. Similarly, you substitute all the values over here. So when you substitute 1, so 1 minus 3 times 1, 3 times 1 is 3, 1 minus 3 will give you minus 2. So the value of y is minus 2. So I am going to write all the values of y correspondingly to the substituting value of x, so that I get values of x and y. Now what will happen when I substitute the value of 2 as x? So 1 minus 3 times 2, which is 6. So 1 minus 6 is minus 5. So the value of y will become minus 5. Substitute 3 over here. So 1 minus 3 times 3. What is 3 times 3? 3 times 3 is 9. So 1 minus 9 is minus 8. So you have obtained some values of x and y correspondingly. Let me draw a table over here for clear representation. So the value of x equal to 0, 1, 2 and 3 so on can give you values of y as 1, minus 2, minus 1, minus 8. Now what I am going to do over here is, well, I have the value of x as 0. Now when the value of x is 0, the value of y is 1. Let me go to this model graph over here. Well, this is a rough graph and I will try to explain this in a clear, better and more explainable way. But as of now, just give some attention to this. Well, when x is equal to 0, y is equal to 1. So where is x is equal to 0 over here? When x is 0, so this is x is equal to 1, x is 2 over here, x is minus 1. Oh well, at the origin the x is 0. Now what is y over there? Y is 1. So where is y 1 over here? So what you are exactly doing is first locate the value of x. So x is 0, so we are taking x as 0. So x is 0 is right over here, and when searching for the value of y, you just go up and down. So the value of y is 1, so you go on this y axis and you get 1 over here. So this is our first point. Mark that point. As of the second value, when x, the value of x is 1, where is the value of x? So 1, let me locate 1 in the x-axis. This is minus 2, minus 1, 0, 1. So this is 1. Well, no, I will not mark it yet. So this is our 1. So this is our 1. And when the value of x is 1, the value of y is minus 2. So where is minus 2 over here? So let me go down. Well, over here the value is minus 2. This is 1, the value of x is 1, the value of y is minus 2. Just draw these dotted lines over here, and this intersection point is your next point. So this is your first point, this is your second point, and when you get these 2 points, it is merely more than enough to draw a line. So get your ruler, start drawing this line accordingly. This is a rough sketch, so it doesn't matter if it comes clearly. So this is your line, which is 3x plus y equals 1. Pretty interesting, right? How can you express this mathematical stuff into a graphical form? Well, this is how you exactly represent it. You just represent it in form of y equal to something, and you substitute corresponding value of x as 0, 1, 2, 3 or any values you find it comfortable, and you correspondingly find the value, what are the values of y, and then plot it accordingly as I have showed you. Now this is the value of 3x plus y equals 1, and when you try it in a graph sheet, well, when you try this same procedure in the graph sheet, it will look in a better fashion and you can clearly see the line over there. Well, we saw what are equations, what are linear equations with 2 variables in it, and what we are going to deal with in this chapter. This is exactly the pair of linear equations with 2 variables in it, and how can we solve them to get 2 different variables. Well, 2 different answers for x and y. We can solve them using graphical method and algebraic method, and we will be seeing these 2 methods in depth in the later videos. And as of this video, well, if you like this video, then like the video, and if you share this, then it will be very helpful for me. And please don't forget to subscribe to the channel, and see you guys in the next video.